All right, day 2 of Plate Boundaries, page 118, chapter 3, lesson 4, Convergent Boundaries. Okay, with our pencil, let's go ahead and skip a line. Capital C-O-N-V-E-R-G-E-N-T, Convergent Boundaries, capital B-O-U-N-D-A-R-I-E-S. These boundaries form where two plates push together. Okay, I think we know that from our drawing, convergent, where they come together. There are 3 types of convergent boundaries. Oh, wow, okay. At continental to continental boundaries, 2 plates both made of continental crust collide. Because continental crust is relatively light, neither plate is subducted. Instead, the land crumples into high mountains. The Himalaya Mountains and Tibetan Plateau formed this way 50 million years ago. Okay, so let's do this. Let's say continental, C-O-N-T-I-N-E-N-T-A-L, dash continental again, C-O-N-T-I-N-E-N-T-A-L. Okay, let's do something simple like an arrow coming together, and nice, tall mountains like that. Okay, basically that just means 2 continents slamming together. At oceanic continental boundaries, an oceanic plate collides with a continental plate. Already see here something changing here, right? Oceanic, basaltic, dense, down below the water. Continental, not as dense, lighter, granitic rock, floats on top. Something's going to happen. Because the oceanic plate is denser, it will be subducted below the continental plate. A deep, narrow valley on the ocean floor, called a trench, forms where the oceanic plate dives down. Okay, we see that here. There's the trench, and you can see it subducting. An even better picture was the page before where you see it subducting down under. There's the trench. Okay, so oceanic, O-C-E-A-N-I-C, dash continental, C-O-N-T-I-N-E-N-T-A-L. Okay, let's draw our oceanic one subducting. Label that oceanic, O-C-E-A-N-I-C. Let's draw our continental one, C-O-N-T period, and draw some shorter, smaller mountains here. Okay, if that's continental, that's oceanic continental. What do you predict is going to be the third one? I bet it's going to be oceanic to oceanic, because that's the only one that's left that we haven't found a combination for. Let's find out. 2 oceanic plates converge at oceanic boundaries. Yep. Okay, now, because of that, we're going to skip a line. O-C-E-A-N-I-C dash O-C-E-A-N-I-C. All right, what happens there? A subduction zone forms as the cooler, denser plate sinks below the other. A trench is formed at this type of boundary too. The Mariana Trench, at nearly 11,000 meters, or 36,000 feet, is the deepest trench on Earth. 36,000 feet. Well, 5,000 feet's about a mile. So let's see, 5, 10, 15, 20, 25, 30, 35, and a little bit more. That trench underneath the ocean is more than 7 miles deep. Wow. I think that's almost the distance from here at school into Wasco City, where the Walmart is. Okay, so let's do this. Let's draw the water on top. So we have the waves, right? Ocean, O-C-E-A-N. Let's have some oceanic crust subducting under, and some other oceanic crust up here. Crust, C-R-U-S-T, crust, C-R-U-S-T, trench, T-R-E-N-C-H. And you probably get some underwater mountains too. But This is so deep, so far below the ocean, that you don't end up seeing the mountains. They don't poke above the water level. 7 miles? Yeah, we don't have any mountains that are 7 miles tall. Okay. Subduction zones are usually accompanied by volcanic and earthquake activity. Okay. Do we know that? Let's write that. Subduction, S-U-B-D-U-C-T-I-O-N, arrow, earthquakes, E/Q, period, comma actually, E/Q, comma, and volcano, V-O-L-C-A, now we have room for it, N-O-E-S, earthquakes, zoop, volcanoes, V-O-L-C-A-N-O-E-S. As the sinking plate melts, some of the resulting magma reaches the surface, forming volcanic island arcs such as the Aleutian Islands of Alaska. Ah, okay. So every once in a while, you can end up getting a little mountain tall enough to stick up out of the water. Okay, divergent boundaries. Let's go ahead and switch to the back of our paper. Capital D-I-V-E-R-G-E-N-T. Boundaries. Capital B-O-U-N-D-A-R-I-E-S. Divergent boundaries form where plates move apart. Okay, we already know that. This usually occurs along the mid-ocean ridges between two oceanic plates. Okay, we already know that, where they're spreading apart. At the mid-Atlantic ridge, plates move apart at a rate of 2.5 centimeters per year on average. That's about 1 inch every year. Okay, that's the Atlantic or the East Coast over by New York, Florida, those areas. Some divergent boundaries are on land. The Great Rift Valley in Africa is one example. Over time, a new ocean basin may form in the gap between the diverging plates. Okay, so you can have a divergent boundary on land. So usually, U-S-U-A-L-L-Y, M-I-D-O-C-E-A-N, usually mid-ocean. Indent can be continental, C-O-N-T-I-N-E-N-T-A-L. E period G period comma, for example given, or for example. Great, G-R, capital G-R-E-A-T. Rift, capital R-I-F-T. Capital V-A-L-L-E-Y. In Africa, capital A-F-R-I-C-A. So, divergent boundaries are usually mid-ocean ridges, R-I-D-G-E-S, but they can be continental, for example, the Great Rift Valley in Africa. And there's a picture of it. And you can see where it's kind of splitting apart and leaving a gap in between. Iceland sits over two plates and the mid-Atlantic ridge. As a result, Iceland is slowly being pulled apart. Volcanic activity and hot springs are common in Iceland. Ah, okay. Along an oceanic divergent boundary. Okay, whoa. Oceanic, the ocean. Divergent, coming apart. Boundary. Okay, so that's the one that's underwater. That's like a mid-Atlantic ridge. Or a mid-ocean ridge. Magma rises through the rift, creating new crust. Oh yeah, we knew that. Okay, when they pull apart like this, the magma comes up and creates new crust. Okay, we remember that. This new crust forms underwater mountains, often as tall as the mountains on land. Oh wow, those are very tall mountains then. Volcanoes and earthquakes are common along underwater ridges. Okay, so mountains, M-T-N-S period, as tall as on land, L-A-N-D. All right, transform fault boundaries. Skip a space, transform, capital T-R-A-N-S-F-O-R-M, fault, capital F-A-U-L-T, boundaries, capital B-O-U-N-D-A-R-I-E-S. Transform fault boundaries form where two plates are sliding horizontally past each other. Okay, there's another image of it, sliding past each other horizontally. Most transform fault boundaries form along mid-ocean ridges between oceanic plates. They form along mid-ocean ridges between oceanic plates. Oh, okay. So let's suppose, let's draw a little picture. Okay, let's say we have these two parts coming apart, right? That would be divergent, D-I-V-E-R-G-E-N-T. But the plates aren't perfectly shaped. So let's say this one kind of goes off at an angle like that, and this one goes along at the same angle. Well, now this one's sliding past, this one's sliding past, and now you're getting a transform, T-R-A-N-S-F-O-R-M. Okay, so some places they diverge, but then when it turns in angles like that, you're going to get transforms sliding past each other. A fault is a crack in Earth's crust caused by sliding plates. Yep, we know that. Most transform fault boundaries form along mid-ocean ridges between oceanic plates. However, a well-known example, the San Andreas Fault, runs along the west coast of California. Okay, so sometimes this can be above ground, and then that's how we have all the mountains and hills along the edge of California over by the coast. So that's why you have to drive over the hills and mountains to get to the coast. That is a big giant transform fault, creating all those hills and mountains. As you have read, the San Andreas Fault Zone is at the boundary of the North American Plate and the Pacific Plate. Okay, so we have two plates that meet each other at a boundary or an edge, and they're sliding past each other, causing the ground to buckle and transform and deform. Part of the California coast, from San Francisco south to San Diego, is on the Pacific Plate and is moving north. The rest of California is part of the North American Plate. This plate is moving north too, but at a slower rate than the Pacific Plate. Okay, so think of it like these two pins are the boundary of the plate. They're both moving north, but this one's moving faster than the other one, and so it looks like they're sliding past each other, and you get that transform fault boundary. You're getting buckling and deforming along that line because one is moving faster than the other. Earthquakes are common as pressure builds up along the fault, then is suddenly released. E/Q, common, C-O-M-M-O-N. So earthquakes are common because you get a lot of pressure building up and then snaps and pops and releases. And then they grind and slide and push against each other and pop, earthquake. You will learn much more about earthquakes, volcanoes, and mountain building when you read the next chapter. All right, pictures, convergent boundary. The Andes Mountains formed at a convergent boundary where the Nazca Plate sinks beneath the South American Plate. Okay, that's down in South America near Peru on the west coast. Divergent boundary. Iceland sits on top of the divergent boundary in the Atlantic Ocean. So this is a picture of Iceland, and this is a picture where Iceland is splitting apart from each other. Transform fault boundary. The San Andreas Fault Zone is a transform fault boundary. Here the Pacific Plate moves past the North American Plate. Okay, so there's an example of the hills, and that is where they're sliding past each other, grinding and splitting. You can see a very well-defined line. What causes faults in Earth's crust? Okay, a fault is a crack in Earth's crust and is caused by movement at the boundaries. So, for example, convergent boundaries cause trenches at the faults where one part of the crust is subducted under the other. Divergent boundaries cause faults because they are splitting apart and causing a rift. Transform fault boundaries cause faults because the plates are sliding past each other, causing earthquakes and rifts. I'm sorry, not rifts, cracks in the ground. All right, we have everything we need to answer this question, so we did a good job on our notes. Good job persevering with the growth mindset. Roar Wildcats!